All right, let's just jump right in. It feels like you can't go 5 minutes without hearing the words artificial intelligence, right? I mean, it's everywhere. It's supposedly changing everything we do. But for a term we hear all the time, it's also surrounded by this cloud of jargon that can feel, well, pretty overwhelming. So that's what we're going to do today. We're going to cut right through all that noise. We're going to build a simple, clear framework to actually understand what AI is, from the basic ideas to the wild stuff we're seeing today.
So, here's the game plan. First, we're going to draw a simple map to help you find your way through all those buzzwords. Then, we get to the really cool part, how machines actually think and learn. We'll take a peek inside the so-called artificial brain, see how it kicked off this huge revolution, and then we'll wrap up by looking at the AI-powered future that we're all walking into right now.
Okay, first up, let's build that map. This is all about getting our bearings in the wild world of AI buzzwords. The goal here is simple. Next time you hear these terms, you'll know exactly what they mean and how they all fit together.
So this is the big one, isn't it? AI, ML, deep learning, what's the actual difference? It's so easy to feel like you're lost in this alphabet soup of acronyms, and people use them interchangeably all the time, often, well, incorrectly. But don't worry, it's all about to click into place.
Okay, the easiest way to think about this is with Russian nesting dolls. Seriously, the biggest doll, the one that contains everything else, is artificial intelligence. That's the whole broad idea of making machines smart. Now you open that doll up, and inside you find machine learning. This is a specific way to do AI. Instead of programming a million rules, you just let the machine learn from data. Then you open that one up, and inside you find the smallest doll, deep learning. And this is a super-powered type of machine learning that uses these really complex, multi-layered networks. And this little doll, it's the one behind almost all of the crazy breakthroughs we're seeing right now.
So we've got our nesting dolls all lined up. AI, then ML, then deep learning. But wait, where does something like data science fit in? Is it another doll? No. And this is key. Think of data science less like a doll and more like a toolbox. It's a whole field of study that just grabs whatever tools it needs, sometimes from AI, sometimes from ML, sometimes from old-school statistics, to solve problems and find insights in data.
All right, so we've got our map. Now let's get into how these things actually think. We're moving from just defining terms to understanding the nuts and bolts of how a machine actually solves a problem.
You know, think about the GPS on your phone for a second. It doesn't just magically know the fastest way to get you somewhere. What it's really doing is treating the city like a massive puzzle. It looks at every possible turn, every possible street, and then it searches for the absolute best path. That's called a search problem, and it's a fundamental way AI solves things. So to really see this in action, we're going to use a classic brain teaser, the old river crossing riddle. But let's update it a bit. A robot, a fox, a chicken, and a bag of feed.
So, how would you or I solve this? Probably some trial and error, maybe a eureka moment. And AI? Well, it has no eureka moments. It's way more methodical, almost brute force. First, it just lists out every single possible safe combination of things on either side of the river. It calls these states. Then it figures out all the legal boat trips you can make to get from one state to another. It calls those transitions. And once it's built this complete map of every state and every legal move, the puzzle is basically solved. It just has to find a path on its map from the beginning to the end. No intuition, no clever tricks, just a perfect, logical map.
Okay, that search method is great for a neat little puzzle where all the rules are known. But the real world isn't like that, is it? It's messy, it's uncertain. You don't always have all the information. So what does AI do then? It turns to its absolute most important tool, probability. You can think of it as the math of uncertainty. It's how a machine can quantify doubt and make the best possible guess, the smartest bet, when nothing is 100% certain.
So we've seen how an AI can think its way through a problem, but the real magic is how it learns to get better over time. And it turns out, in the whole world of machine learning, there are really just 3 main ways it does this.
Let's break them down. First up is supervised learning. The best way to think of this is like studying for a test with flashcards. The AI gets a question, say a picture of an animal, and it also gets the answer, cat. It does this millions of times until it learns to recognize cats on its own. Next, we have unsupervised learning. This is what happens when the teacher leaves the classroom. The AI gets a giant pile of data with no labels, and its job is to just find interesting patterns, like finding natural groups of customers in shopping data. And finally, there's reinforcement learning. This is exactly like training a dog. The AI tries something, and if it's a good move, it gets a reward, a digital treat. If it's a bad move, it gets a penalty. It just keeps trying things to maximize its treats.
But with any kind of learning, there's a really common trap. It's called overfitting. And it's basically what happens when the AI doesn't learn the general lesson, it just memorizes the answers to the test. This quote is such a perfect example of that. You get this crazy, super specific rule because the model didn't learn what makes a song a hit, it just memorized a bunch of random coincidences in the data it was trained on. A rule like that is totally useless for predicting the next hit song.
So all this learning, and especially the really powerful deep learning stuff, is powered by something called a neural network. And it's directly inspired by, you guessed it, the human brain. But this is so important. The key word is inspired. It's not an imitation.
And honestly, this quote just says it all. We learned how to fly by watching birds, right? But we didn't build airplanes with feathers that flap. It's the same idea. Researchers looked at the brain, understood the basic principles of how neurons fire and connect, and then they used that idea to engineer something totally new. It's about capturing the function, not copying the biology.
So what does one of these artificial neurons actually do? Well, it's surprisingly simple, really just a two-step process. First, it takes in a bunch of signals, and for each signal, it multiplies it by a weight, which is just how important that signal is. Think of it like a grocery bill. You add up the price of everything, but you multiply apples by the price of apples and oranges by the price of oranges. After it adds all that up, it does step two. It passes that total score through something called an activation function. And you can just think of that as a simple yes or no switch, or maybe a dimmer switch, that decides if this neuron is going to fire and pass a signal on to the next neuron.
Okay, so one of these artificial neurons on its own, it's not very smart at all. But what happens when you connect millions, or now even billions of them together into these massive layered networks? Well, that's when you get the AI revolution. Let's look at the big three specialized networks that really changed everything. Modern AI isn't just one thing. It's a bunch of specialized tools. First, you have CNNs. Think of them as the eyes of AI. They're amazing at understanding images because they learn to spot simple things like edges and corners, and then build those up into more complex shapes like faces or cars. Then you have GANs, the artists. This is such a cool idea. You have two AIs compete against each other. One tries to create fake images, and the other tries to tell if they're fake. And through this battle, they learn to create unbelievably realistic, totally original art. And then, of course, you have LLMs, the communicators. These are the models behind things like ChatGPT. Their secret sauce is something called attention, which lets them understand the context of a whole sentence, not just the words next to each other, which is why they can have such a natural conversation.
And when these technologies, especially LLMs, finally hit the public, well, this happened. 100 million. That's the number of users ChatGPT got in just its first 2 months. To give you some context, that is the fastest growing application in the history of the internet, period. Nothing else even comes close. People called its release a metaphorical earthquake, and that's not hyperbole. It really was. This was the moment the ground shifted under our feet. AI went from being this abstract concept talked about in university labs to a tool that you, me, anyone could just open up in a web browser and start using. Everything changed, seemingly overnight.
And that brings us right here to today, to our AI-powered future. And as this incredible tech weaves itself into our lives, we have to talk about the really big choices and the really big challenges that we're all facing.
There are a lot of them, but here are 4 of the huge ones. First, algorithmic bias. If AI learns from our messy, biased human data, how do we stop it from just becoming a mirror for our own worst prejudices? Second, AI fakes. What do we do in a world where you can no longer trust a video or a photo, or even a voice, where seeing is believing just isn't true anymore? Third, privacy. How do we protect our personal information when AI can de-anonymize massive datasets? And finally, the big economic question. How do we make sure that the immense wealth created by AI doesn't just go to a tiny few, but benefits everyone?
And of course, there's the one on everyone's mind, jobs. You've probably seen a headline with a number like this one, 47%. That comes from a really famous Oxford study that estimated almost half of US jobs are at high risk of automation. And yeah, that's a number that's designed to grab your attention.
But here's a good rule of thumb. Whenever you see a prediction that's that precise, you should be a little skeptical. It's what's known as the illusion of accuracy. Look, the real takeaway isn't that specific number, 47%. It's the trend that matters. What these studies are really good at is showing us the kinds of jobs, the ones that are routine, predictable, and repetitive, that are most likely to be transformed by this technology.
Which really brings us to the most important point of all. This technology, AI, it's not some unstoppable force of nature. It's not a tidal wave that's just going to wash over us whether we like it or not. It is a tool, a powerful one for sure. But its future, its impact, is going to be determined by the choices we make, the rules we write, and the kind of world we want to build with it. The future isn't written yet. As a wise person once said, there is no fate but what we make for ourselves. Stay curious.